Hello, my name is Rijad Šišić. I'm a professor at University of Tuzla, Faculty of Mining, Geology and Civil Engineering. Today I will give you a short introduction to hazard and risk theory, and also through my presentation you will see two case studies. So let's start from the beginning. We all face risks of some sort, as individuals, business or society. We need to understand, describe, analyze, manage and communicate these risks, and disciplines of risk assessment and risk management has been developed to meet this need. So, first of all, let's define the terms. There is a large number of definitions of the terms hazard and risk. This is a consequence of different directions from which people approach risk areas. For example, a hazard is any agent that can cause harm or damage to humans, property or the environment. While a risk is the chance, high or low, that any hazard will actually cause somebody harm. It is extremely important to distinguish between the meaning of the terms hazard and risk, which are often mixed or considered as terms that describe the same phenomenon, sometimes even in a serious public conversation. Once again, hazard is anything that can cause harm to the people, and the risk is how great the chance for that to happen. Hazards can be dormant or potential with only a theoretical probability of harm. An event that is caused by interaction with hazard is called an incident. Hazards can be classified as different types in several ways. For example, based on energy source, based on origin, or based on effects. The first level of protection is the possibility of physical elimination of hazard, and if this is not possible, hazard control measures are used. Hierarchy of hazard control is a system used in industry to minimize or eliminate exposure to hazards. Control methods at the top of the figure 3 are potentially more effective and protective than those at the bottom. Following this hierarchy normally leads to implementation of inherently safer systems where the risk of illness or injury has been substantially reduced. Evaluation of the risk of technical system is developing relatively late in relation to other areas. The first analyses were about lifetime of ball bearings in railway at the beginning of the 20th century. From that time there is a story about the Bayes principle. The strength of the chain is the same as the strength of the weakest link. But risk is more than calculated numbers. Risk acceptability and tolerability cannot be defined based on risk assessment alone. A balance has to be struck between different concerns like social, cultural, economical, etc. To do qualification and quantification of some risk, we need mathematical basis. Quantitative analysis involves some formal methods like probability of event, statistics, and different mathematical tools and concepts. One of the first mathematical concepts used was expected value. It is obtained by multiplying each possible outcome with the associated probability and summing over all possible outcomes. Average value converges to expected value when the number of experiments goes to infinity. The expected value is the key concept in risk analysis and risk management. But it is impossible to restrict the risk evaluation to simple comparison between numbers. Uncertainties behind the probabilities needs to be taken into account. Perspective risk is equal to uncertainty is the most common in business context. Risk refers to uncertainty of outcome, actions and events. The idea that risk equals uncertainty seems to be based on assumptions that the expected value is the point of reference and that it is known and fixed. Risk does not exist independently of the assessor, and the uncertainties are somebody's uncertainties. Another often considered approach is risk equal event. Risk is a situation or event where something of human value, including humans themselves, is at stake and where the outcome is uncertain. Two perspectives are evident in considering approach to risk. First, discipline-based and second, model-based. These four basic approaches, each originating from an independent disciplinary tradition, are technique, economic, cultural and psychometric. In addition to basic, there are also concepts of meta approaches like political, socio-emotional, adaptation and evolutionary. The different approaches to risk illustrate the multifaceted nature of risk and emphasize the need to take a multidisciplinary approach to understanding and managing risk. After the hazard is detected, risk assessment takes place. Risk assessment consists of an objective evaluation of risk in which assumptions and uncertainties are clearly considered and presented. The risk assessment consists of several steps: identification of risk, estimating potential consequences, probability of occurrence, and acceptability of the risk. All these 4 steps should give ways to mitigate or reduce probability of the risk. Risk identification is not always an easy and simple procedure, and is crucial for the quality of risk assessment. It is necessary to know the problem for which the risk assessment is carried out. The possible difficulties best illustrated the following simple example from everyday life. Flour will not be considered from many to be hazardous substance. Many of us using it every day. However, if the flour is raised and mixed with air in certain proportion, it will become explosively dangerous with possible devastating consequences if the explosion occurs. In this way, a harmless substance under certain conditions becomes a high-risk substance. All this leads to the conclusion that risk assessment is a mandated science. Neither pure science nor pure public policy, risk assessment reports are hybrid of both. The result of the risk assessment process is a document, also termed as risk assessment, which represents the risk findings and describes how they were generated. Next figure shows structure of risk assessment project management. All true, experts approach risk management process from different aspects of human activity. The basic principles of the process itself do not usually differ. The general algorithm of risk management process is shown in the following figure. Disaster risk management is a complex and multidisciplinary problem involving the engagement of technical disciplines as well as social, economic, and other expertise. As an example, we will look at the management of environmental risks as an important segment of disaster risk management. Environmental risk assessment is an organized process used to describe and estimate the likelihood of adverse health outcomes from environmental exposures to chemicals. Steps of risk assessment are hazard identification, dose response assessment and categorization, prevention, control and reduction, avoiding unacceptable, intervent response, and risk transfer. At the end of the process, one question always arises. What are we managing, or what we can manage at all? These are probability and consequences of the realization of hazard. Disaster risk management is closely related to natural hazards and dynamics of catastrophic events. Some events take place very quickly, like earthquakes, explosions, while others last for a longer period of time and leave more time to manage. This will greatly determine the methods and possibilities for risk management. The goal of risk management is scientifically sound, cost-effective, integrated actions that reduce or prevent risks while taking into account social, cultural, ethical, political, and legal consideration. The extent to which this area is considered important in preventions of human lives, health, property, and environment is best illustrated by the fact that the International Organization for Standardization has defined the whole field roughly through ISO 21000 risk management principles and guidelines on implementation. Today, we have many methods of risk assessment and management. Most of them are of general nature and are applicable to the analysis of all types of risks, but there are also specially developed methods for specific conditions. These are some of the most used. Preliminary hazard analysis is a simple and fast method through which the way of functioning of risk assessment can be easily demonstrated. The basis is the establishment of a risk matrix, probability of occurrence multiplied by consequences, and the categorization and the calculated risk according to this matrix. In risk matrix, consequences are divided in 5 categories: insignificant, low, medial, significant, and catastrophic. While probability of occurrence is marked by the letters A, B, C, D, and E. By multiplying different probability of occurrence with consequences, we can get 4 types of results: E for extreme risk, H for high risk, M significant risk, and L low risk. The application of the risk assessment methodology will be presented in 2 short examples. Example 1 is related to wide landfills. The study has examined the environmental risk assessment associated with unregulated landfill site in a municipality in South African province. The determination of the environmental risk was achieved by the use of questionnaires, surveys, and landfill analysis forms in selected study areas. Picture shows 3 wild landfills in study area. The findings have highlighted a very high environmental risk, nearly 4 times and above the threshold limit set by authorities for all the landfill sites examined. Several exposure pathways stemming from associated environmental impacts have also been identified for the study. The higher environmental risk determined for the problem sites is ascribed to numerous factors, including their ill-planned location, the sensitivity and vulnerability of the natural environment and adjacent rural settlements, the lack of appropriate waste pre-treatment process prior to disposal, and most significantly, the lack of regulatory and control measures to contain the myriad of environmental problems generated. Results of questionnaires and surveys are presented as a public perception of the probability of the various exposure pathways in the next picture. Environmental risk can be estimated by multiplying the frequency of exposures by severity of environmental impacts. The data analyzed in the current study was used to determine frequencies or the number of exposures as well as percentage characterizing the severity of associated environmental impacts. The occurrence of exposure pathways were calculated through an examination of the number of all instances that have potentials to cause environmental hazards per study area. These instances were determined by analyzing the data on the completed questionnaires. Also, risk probability was determined by analyzing questionnaire response which dealt with aspects such as proximity of residential households and water bodies to landfill sites, the consumption of discarded food by reclaimers, etc. In conclusion, it is recommended that several measures, including closure, should be taken in order to reduce and contain the magnitude of environmental risk involved. While the first example was a more traditional presentation of the use of the preliminary hazard analysis method, another example of flood risk assessment is much more current with the use of modern satellite and LiDAR images and spatial data analysis. Flood risk is the product of hazard, that is the physical and statistical aspects of the actual flooding, and vulnerability, that is the exposure of people and assets. The example presents a case study on flood hazards and flood risk assessment in the local spatial scale using geographic information system, remote sensing and hydraulic modeling. As for determining flood hazard in the model area, which has 3.23 square kilometers located in the Nitra River basin in Slovakia, the estimation of maximum flood discharge and hydraulic modeling were important steps. Meteorological, hydrological and hydraulic investigations to define the hazard and estimation of the flood impact to define the vulnerability can be performed separately in the first place but have to be combined for the final risk analysis. Today, this kind of analysis required the application of different data or specialized software, and some of the results can be seen on the picture. Flood intensity was determined by using first equation. Based on these calculated intensities, the categorization of the hazard was made using the following table. The results of calculation are displayed as spatial data on the map of observed area. This way of displaying spatial data is now commonplace for vulnerability assessment, risk maps, distribution of contaminants, etc. The picture shows the vulnerability map of area of observation with categorization on low, medium and high vulnerability in relation to purpose and occupation of surfaces. The great advantage of digital and spatial processing of risk analysis data is the possibility of analyzing different scenarios and the dynamics of the phenomena we observe. The following illustrations show the risk map of massive water discharge scenario for the Nitra River. All of us, as individuals, face the daily risk assessment and risk management. when crossing the street, when preparing the lunch, when thinking about investing money, we always subconsciously and automatically assess, compare, get informed, and finally make decisions. This is nothing but risk management. However, in everyday life, when it comes to small but even to more important decisions, uncertainty and probability are often well known to us and easy to estimate. Usually, we rely on experience and information gathering from the environment. Even in the case of wrong estimation and wrong move, the consequences are usually individual, such as tasteless lunch. In industry and business, uncertainties and probabilities are harder to determine and evaluate. This is a consequence of large number of influencing factors and correlations between them. To do better and more accurate risk assessment, a large number of general and specialized methods has been developed. However, the question, what is acceptable risk, is always arise. Scientific and technical conclusions often do not coincide with political and social aspirations and norms. This is why the answer to this question is always a technical and political decision. On the other hand, risk and perception of risk are not always in line. Very often, public perception is formulated through public information services, and the transferred information may be incompetent and untimely. Once posted, wrong information in the public can declare some risk high, although it may not be, and vice versa. Therefore, competence and transparency in the risk assessment and management is very important. The effects of proper risk management are difficult to assess. The most reliable way to determine the effects will be to not manage the risk. In this way, we will return to passive control, that is, learning from errors, which is not acceptable in today's world. Finally, the most common question that risk management experts hear from employers or society is, how much does risk management cost? For the answer, we can use a brief analysis from the picture shown. If the level of risk is high, the application of reduction measures is not called into questions, as well as their price. However, most of expertise belongs to the area of medium to high risk, whose cost of assessment and management can be relatively low to extremely high. Low risk activities and high cost of management are in the known economic sphere of activity. Finally, the best answer to the question how much risk management cost will be how much will it cost to not manage the risk.